Okay, let's give this question some consideration. This is the type of thing that is probably more important than just calculating numbers, because you have to use some logic and understanding about things in order to determine whether something is feasible or not. So anyway, how do you answer a question like this? Well, basically what you do is you try to see if all of the laws of physics are satisfied. The only thing that we've been studying in this class, well, two things. One is the conservation of mass, and the other one is conservation of energy. So in a particular case like this, there's not much to be talking about with the mass, but think about the energy. So what I'm going to do is pause this, but in order to answer this, what you want to do is think about the energies in this gas and ask yourself, is it possible that you could satisfy the energy equation? So I'm going to pause, you think about it, and then I'll come back. Okay, so here's some thinking. Let's think about the energy that goes in and out. Isothermal, what that means is that the gas is constant temperature. Means constant, thermal means temperature. So it's a constant temperature gas. When you're compressing the gas, you're increasing the energy. You're putting energy into the gas. The word adiabatic means that there is no heat transfer. There's no thermal energy that is transferred in or out of the system. So think about those things and in relation to the energy equation and see if you can answer this question. I'm going to pause it and you think about it. Okay, here is a section that I'm showing from the summary of the book in chapter 5. For an ideal gas, if you notice, the change in internal energy right here is the coefficient of specific heat, CV, times the change in temperature. So that's the change in internal energy for the system. Okay, so let's take a look at our other system. And in the black here, I'm showing a system with the gas. Because it's isothermal, the temperature is constant. So from the notes from the chapter, mass times CV change in temperature, that's 0 because the temperature is not changing. So there's no change in the internal energy of the gas in the system. Because it's adiabatic, the heat transfer is 0, but yet there's an energy that goes in because of the compression. So if you drop all these 0 terms, you end up with this in red. You have the work of compression has to be equal to 0. Well, there's no way you can compress a gas without putting the energy in. So therefore, the answer is no, you cannot do this. And the reason is because there's no place for that energy to go. It either has to heat up or you're going to have to remove the heat through Q. Okay, that's it.